First of all, I would like to thank Professor Ghenazzani and the organizing committee for having invited me to share with you, which I do consider as not only new data, but I should say to share with you a new concept that appeared during the last 1 or 2 years, which is the fetal origin of disorder of puberty. I don't have any conflict of interest. I'm on the left. So, as everyone in this audience is aware, the initiation of puberty has been considered as the activation between the age of 12 or 13, the reactivation of the GnRH pulse. And we knew that GnRH pulse activity did exist during the fetal life. It's reactivate in early life with the so-called hyperactivation of the gonadotropic axis in the first 3 months of life. And after a long period of quiescence, it's reactivate before the onset of puberty. As a matter of fact, this is always true, but we should consider that the GnRH activity can be modulated during the fetal life by several factors that could impact the onset of puberty and even more disorder of puberty. This is a fascinating aspect which belongs to the so-called the fetal origin of adult disease, but puberty is not, as far as I know, is not a disease. But you will see that we discover this new concept through disorder of puberty, precocious as well as late puberty. So the timing of puberty in girls is strongly influenced by genetic regulation. We know, and this has been confirmed by the NIAST study. We think that 50 to 70% of the variation of timing of pubertal onset is under genetic control. But what we learned recently is the fact that the onset of puberty can be modulated by energy balance, but not only postnatal balance, but also prenatal balance, which is new, and also by fetal exposure to environmental disruptor chemical, not only postnatally, but also prenatally. And this is completely new. So, during my short talk, I will remind you the genetic basis of disorder of puberty, the fetal nutrition and disorder of puberty, and the fetal exposure to endocrine disruptor and disorder of puberty. Regarding the genetic basis of disorder of puberty, just to remind you that there are two conditions I will talk about: the precocious puberty, which is considered in girls when telarchy or the breast development starts below the age of 8, and delayed puberty, defined by the absence of breast development by the age of 14. But the first new data I would like to share is that the mean onset of puberty can be modulated by genetic variant that has been identified from NIAS study. So this is the genetic basis of pubertal onset. And for those who are not familiar with this topic, it's become recently more and more complicated. But I will give you some key message. Puberty is related to the synchronized pulsatile GnRH. The key actor is a GnRH neuron, and this GnRH neuron can be modified by genetic message coming from the glial cell, from the other neuronal cell, and you heard about the Kindi neuron, the glue neuron, the GABA neuron, and so on. I don't have enough time. Leptin neuron, and so on. So the GnRH neuron is modulated by other genetic factor or metabolic factor through some specific target gene, the most common being the KIS and KIS1 receptor, along with other genes like the TAC3 receptor. The second message, which is also very important, that above the GnRH secretion, there are several integrated messages coming from upstream gene, and namely a transcriptional regulator gene that modulate the GnRH activity, and some of these genes acting through the epigenetic mechanism. So a simple mechanism, GnRH neuron modulated by other gene under the regulation of upstream gene, and namely a transcriptional factor. So what do we know about the gene associated with delayed puberty that correspond to the fetal origin of delayed puberty? The most fascinating gene has been discovered some years ago, maybe 1 or 2 years ago, is the EGSF gene. Very briefly, this gene, when it's mutated, disruption of this gene represents the typical fetal origin of delayed puberty, because this gene is responsible for the GnRH neuron migration. Has been reported for GnRH from KIS and other genes involving neural migration. This IGF-1, IGSF-10, is involved in some specific migration during the fetal life. Each genetic defect may result 10, 12 years ago, may result in delayed puberty. So this is a typical aspect of the fetal origin of delayed puberty. And as you can see, this gene has some connection with the GnRH neuron, is expressed during or after puberty through a reduction of the GnRH gene activity, since there are less GnRH neurons. As a matter of fact, there are several gene abnormalities, whatever it's gene mutation, I should say rather gene polymorphism, that could explain some fetal origin of delayed puberty. And beside EGSF-10, there is a gene coding for transcriptional factor, FTO, who is also responsive. There is another transcriptional factor, EAP, I talked about previously, and other genes you heard about that are associated with hypo, like TAC1, TAC, and GnRH receptor. So the main message is the fact that during the fetal life, some genetic polymorphism or genetic defect may be responsible for delayed puberty that occur later on, which is a fascinating concept, I think, at least for me. Regarding early puberty, this is also a new topic. And I don't have too much time, but just to remind you that there are some genetic defects, two main genetic defects, MKRN3, which is a gene involved in the regulation of GnRH, as well as DLK, that are associated with early puberty when they are mutated, because these two gene codes for protein involved in the break of GnRH. So a mutation in the break induces an activation of GnRH. I hope I am clear enough. This is the last factor whose mutation has been reported some weeks ago. It's a DLK, which is now considered as a gene involved in the link between reproduction and metabolism, because DLK is a factor involved in adipogenesis regulation. And we start now to have a new aspect of the link between adipose tissue and reproduction. Moreover, there are some recent data that clearly demonstrate that through the methylome analysis, we do have some specific change of what we call zinc finger gene involved in the regulation of GnRH. So the main message, pubertal onset as well as pubertal disorder may be associated to epigenetic abnormal regulation. So this is a new concept of the genetic basis of delayed puberty. As you can see on the top of the slide, there is you can see the gene associated with early puberty, with precocious puberty that starts in the fetal life. So it's exactly the topic Professor Gennady asked me to deliver. It's a genetic basis, it's a fetal origin, and on the lower part of the slide, the gene associated with delayed puberty, FTO, EGSF, EAP, and so on. So you can see that during the last few years, the molecular genetic has completely brought the data to revisit the so-called idiopathic precocious puberty as well as idiopathic delayed puberty, which is very exciting data. The second one, which is not as new as the first, is the role of fetal nutrition in disorder of puberty, which is also for many, maybe for many of us, a new aspect. What is there any link between fetal nutrition and disorder of puberty? And the answer is yes. We do know that in girls with IUGR, intrauterine growth retardation, catch-up growth is associated with early puberty. We know there are several data that confirm that small fetus, small female fetus, may present early, in the pubertal period, an earlier onset of pubertal, earlier age of pubertal onset. Intrauterine, early pubertal onset. There are other factors besides fetal nutrition that interfere with the pubertal timing. Another example, recently reported and confirmed, because we had this information before, that pregnancy smoking has impact 10 or 12 years later on the pubertal onset. In other words, fetal or pregnancy smoking is associated with early puberty in girls. This is also a new aspect of the fetal origin of disorder of puberty. New data report that earlier onset of puberty, I'm talking only in female, and the early onset of female puberty can be associated with gestational diabetes. So in other words, hyperglycemia during 2 minutes more. It's over? Time is over? No.
No, you have
2 minutes. Okay. So recent data from very good group reported that there is a link between fetal hyperglycemia and early onset of puberty in girls. So this is another factor that could modulate another fetal factor that could modulate the pubertal onset. And this has been confirmed some weeks ago in one of our best journals, Journal of Pediatrics, which is our Bible for pediatricians, that clearly report the link between fetal hyperglycemia and early onset of puberty. And the last factor, besides genetic factor, after nutritional factor during the fetal life, is there any link between the fetal exposure to endocrine disruptor and the onset of puberty in girls? And I just want, I just want to show you that there is a link. This work report that there was a relationship between the phthalate concentration in the pregnant woman and the onset of puberty in girls. And as you can see, there is a link between bisphenol A, maybe you heard about bisphenol A, and phthalate, which are plastic, that are present in our environment, and they follow these pregnant women for 15 years, and they demonstrate that their girls did present early onset in puberty, and this early onset was correlated with the level of phthalate derivative and bisphenol A concentration. And as a matter of fact, we knew for many years from a wonderful work published in Nature, by treating pregnant rat with bisphenol A, we can induce early onset of puberty in the female rats born from this treated rat. This work from Anderswell, published in Nature 20 years ago, is now confirmed by several experimental data I don't have time to talk about, and just before, phytoestrogen also are associated with early menarche. And I would like also atrazine, which are pesticide, in neutral exposure to atrazine may induce early onset of puberty in girls. So in clinic, there are enough data that link prenatal contamination and early onset of puberty. And this is a beautiful work recently reported, I think it's some months ago, that identify the mechanism of action in rats of the relationship between fetal contamination and premature puberty in female offspring. As a matter of fact, they demonstrate that this can be linked to an epigenetic mechanism based on the increased methylation of some transcription factor involved in the regulation of GnRH secretion. Is not beautiful? I mean, the endocrine disruptor increased the methylation of some transcriptional factor regulating upstream regulating the GnRH production. And this is the first experimental demonstration that the fetus that are now contaminated everywhere in the world may present an increased onset of puberty or increased onset of breast development and precocious puberty. This has very important sanitary concern. So, in conclusion, recent exciting evidence highlight the importance of regulation of the GnRH during the fetal life, and fascinating heterogeneity of genetic defects has been shown to result in disordered puberty in women, and puberty can be considered as the consequence of neurodevelopmental programs that begin during the fetal life, but this program that starts in the fetal life can be influenced, modified by epigenetic mechanism, nutrition, endocrine disruptor, and also by endocrine disruptor directly or through epigenetic mechanism that could impact later in life the onset of puberty. Thank you for this oldest school of medicine in the world, which is Montpellier. We do have the oldest school of medicine in the world. I would like, Mrs. Chairman and friend and colleague, thank you for your attention.
Thank you very much.